Okay. All right, so for this one, it's pretty much, it's pretty, okay, so to determine the, okay, so number one, determine voltage VRD for the circuit shown, okay, circuit shown right here. So they want the voltage drop over RD. So now you have the current and you got the resistance. So you take the current times the resistance, that's where you get the 5 volt DC, okay? So the answer is A as in apple for number one, okay? And number two, determine voltage Vs for the circuit shown, okay? So for the circuit shown, so VG is 0 volt. Now Vs, we do not know what it is, but we take the current here, multiply this one to get the value of Vs. Okay, so we're taking 5 milliamps. So 5 milliamps times, that is in ohms. So we convert that to kilo ohm. So that's 0.22 kilo ohm. So that's giving us 1.1 volt. Okay, so RS would be 1.1 volt. So VG minus the VS would be, so it's going to be minus 1.1 volt. Oh, just they want as a VS. Okay, so VS is just here. So take the current times this here, and that will give you your voltage, okay? And so this is milliamps. So you have to convert this onto a kilo ohm. So the kilo would undo the milli, okay? So 5 times 0.22, that will give you the 1.1 volt DC. So the answer is C as in cat for number 2. Okay, let me click on the chat real quick. Looks like someone's coming on the chat. Oh my God. Okay. No, there is not. Okay, well, you can, everything is going to be recorded, so you can watch the YouTube later on when you have time, okay? So number 3, determine voltage VGS for the circuit shown. Okay, so like I said, so VG is 0, VS was 1.1, so VG minus VS will be minus 1.1 volt DC, okay? So the answer is A as an apple for number 3. Okay, any question number 1, 2, or 3? Okay, everybody's good. Next set. Okay. Let me see, I can rearrange this a bit. Hopefully that doesn't change to the next. Hopefully everybody can see that clearly. If not, then let me move this one up a little bit. Okay. Okay, number 4, if the drain current of the circuit shown is increased, VDS will. Okay, so you increase the current, but you're going to be decreasing the, so if the current would be increased here, so if you keep everything constant, just almost follow Ohm's law. So if you increase the current, you have to decrease the voltage, okay? So the VDS going to be decreasing. Let me see, if the drain current, if the drain current of the circuit is increased, VDS will, okay, yeah, so VDS, so this one is going to be increasing a little bit. This one's decreasing, increasing VD. Okay, just kind of sit there and calculate a little bit. Okay, so the answer is B as in decrease for number 4. Okay, number 5, the circuit is shown. Okay, so the circuit is shown since they only have one power supply, which is the bias power supply, that's what considered the sub-bias, okay? So the answer is C as in cat for number 5. Okay, number 6, okay, this one is a little bit more take me a little bit more time to figure out. Okay, so IDSS equal 20 milliamps, and VGS off if -6 volt for particular JFET. What is ID when VGS is equal to 0 volt? Okay, VGS at 0 volt, it would be at the maximum. The ID would equal to IDSS. Okay, ID here would be equal to IDSS. So therefore the answer is A as an apple for number 6. Okay, number 7, IDSS equal 20 milliamps and VGS off equal -6 volt for a particular JFET. What is ID when VGS equal VGS off? Okay. Okay, so at that point there won't be any current at all. So okay, so the answer is B as in Bob for number 7. Okay, any question? 4, 5, 6, or 7? Okay, look like we still have technical difficulty on the other end. Okay, so, oops, okay, number 8. Okay, determine the value of VGSQ from the circuit shown. Okay, so we look at, so S is here. So G is going to be G is going to be -2 and S is going to be 0. So VGS, so VG minus VS, so -2 minus 0. So it's -2 volts. So the answer is B as in Bob for number 8. Number 9, determine value of IDQ for the circuit shown. Okay, so the answer is C as in cat, 5.63 milliamps. Okay, so IDQ, we're going to be using the form, you apply the formula here. Okay, let me calculate that real quick. So we with 10 times 1 minus VG, yes, okay, minus -2 divided by -8 and that quantity square. Okay, come into about 5.625 milliamps. So the answer is C as in cat for number 9. Okay, any question number 8 or 9? Okay, determine the value. Okay, number 10, determine the value of VD for the circuit shown. Okay, so VD is going to be right there. So VD is at this point. Okay, so in this point, you're going to be 16 volt minus the voltage drop here. So 16 minus ID, going to be ID times the 2, and that should be your. Let me see, VG, okay, so we got B. Okay, so we got the current that was here, 5.63. Okay, so 5.63, so 16 minus 5.63 times 2K. Okay, come to 4.74. So the answer is B as in Bob for number 10. Okay, number 11, determine the value of VDS for the circuit shown, okay? So VDS, okay, so we got the VD is at 4.74. VS is at 0 at a common. So therefore the answer is going to be 4.74 volt. The answer is C as in cat for number 11. Number 12, when JFET is at cutoff, the depletion layers are, okay? So when you're at the cutoff, so pretty much they're gonna be touching each other. They're gonna be touching. So it's gonna be, so C is touching. So it's gonna be pretty much, the answer is C as in cat. Okay, any question 10, 11, or 12? Okay, page down. Let me see if I can. Okay, 13, given the VD in the circuit shown is 5 volts, solve for ID. Okay, so VD is 5 right here. So it's going to be 9 minus 5 divided by your resistant value here. So 9 minus 5, that would be 4 divided by 4.7. So that is 0.85 milliamps. So the answer is B as in Bob for number 13. Okay, given the VD in the circuit showing is 5 volts, solve for VG. Okay, so VG here. Okay, so 5 volt here. So we're going to be taking the 9 times R2 divided by the quantity R1 plus R2. So 9 times 2.2 divided by 10 plus 2.2. So the answers come to 1.62 volt for VG. Okay. So the answer is A as an apple for 14. Okay, number 15, given the VD in the circuit showing is 5 volts, solve for VS. Okay, so VS here. Okay, so VS. So we're going to be using the same current that we used earlier. So the current from the ID in the previous step was 5 point. I think it was 5 point. 5 point. Okay, so VD was okay, so that was based on that circuit. So we're going to be looking at this circuit. The current was, okay, ID was 0.85. Okay, 0.85 times 3.3. Okay, so that gives you a 2.805 volt. So the answer is C as in cat for number 15. Okay, any question number 13, 14, or 15? Okay. Now number 16. Okay, so 16. The pinch-off voltage has the same magnitude as the VGS off at the cutoff. Okay. At the VGS off or the VGS off. So going to be the pinch off. It's the same magnitude, but it's going to be the pinch off is positive and this is going to be negative. Okay, the answer is D as in David for number 16. Number 17, the transconductant indicates how effectively the input voltage controls the output current. So the answer is D as in David for number 17. Number 18, a JFET has IDSS equals to 20 milliamps and VP equals 3 volt. What is the drain current at VP equals 5 volt? Okay. So pretty much, so you have the pinch off, which is at 3 volts. So anything beyond 3 volt, it's not going, won't be any more current because it's going to be cut off completely. So you're going to be at 0 milliamps. Okay, because VP now is at 5. It's beyond 3. Okay, from 0 to 3, you're still going to have some current, but anything beyond 3, it's going to be completely cut off. So the answer is C as in cat for number 18. Okay, page down. Okay, so that's done for number, so that's a review, review number 3.
3. Yeah.
Okay. So I'm going to be, okay, so we're going to be close this one. So save it. No, I don't need to save it for now. Minimize it out the way. Next one.
Hello, Sam.
Yes, Mr. Pham.
Let me run the next one.
Okay. Stop sharing. Okay, go ahead.
Okay, you guys see the screen?
Yes.
Okay, that's number one. The channel of JFET between what? If you're looking at the beginning and you understand the channel will be between the drain and the source. Okay, so number one will be B. Number two, JFET is they will be a unipolar device and voltage controller device. You understand the bipolar and PNP transistor will be current controller device. Number two will be D. Number three, for VGS equals 0, the drain current becomes constant when VGS exists. You know that VP, ping up voltage. Number four will be C.
That was
Number
number
four.
three. That was number three, should have been C.
Number three will be C. Number four, JFET always operate with, answer will be the gate to the short PN junction, but they must be reversed bias, okay? In bipolar, they will be forward. Number five, constant current area of a JFET lie between. You remember, that will be between ping up and breakdown. After the bring up, they working like ohmic region. IDSS is the maximum possible drain current. So number 6 will be C. Number 5 will be D. Okay, number 4 will be A. Seven, drain current in the constant current area increase when the gate to the short bias voltage decrease. If you're looking on the graph display for the current, the voltage and the current ID. So if you try to increase the current, okay, send the gate to the short bias voltage will be decreased. You understand the VGS 0 and the current go to the maximum IDSS. Okay, number 7 will be A. Number 8, in a certain FET circuit, VGS 0, VDD 15 volt, IDSS 15 milliamp, and RD equal 470 ohm. if RD decrease to 330 ohm, IDSS equal. The answer will be C, 15 milliamp. You know why you get 15 milliamp without any calculation?
ID equal IDSS.
ID equal IDSS. That's only telling you RD you changing it not affected. Okay. The thing is why I said they not affect to the ID. How come you know that 15 milliamp? I understand. They equal IDSS. How? Who can tell me? Mr. Smith.
Go ahead, Mr. Pham.
Yeah, you get the right answer, but my question is how?
Well, ID and IS is the same, and if it's I'm just looking at the answer. I'm probably wrong on this, but if the answer is 15 milliamps, then ID and IDSS are the same.
Why they be the same?
I forget one area you have like saturation, and the other area you have cutoff. So is that because of saturation?
Okay.
Because you on one axis you have one thing, and on the other axis you have something else.
Okay, I can tell you. The reason the ID equal IDSS, the thing that they given to you, VGS equal 0. See that? If VGS equals 0, no matter what, ID have to be the same, IDSS.
All right. Hey, Mr. Pham, also too, as I was saying, on your y-axis, you have where IDSS is, that's saturation, correct?
Exactly.
And then on the x-axis, you have cutoff on the bottom end.
On the bottom, that what?
VDS?
VDS.
Okay.
However, they show you on that graph a ID equal IDSS with VGS must be equal 0.
Okay.
Okay?
All right.
That's number C on 8. Number 9, at cutoff JFET channel, answer will be completely closed by the deletion region. So number 9 will be B.
Hey, Mr. Pham, I don't want to mess up anything, but can you go back to that number where it had 654, the screen before this one?
Okay. Okay, which one? Number 4, 5, or 6.
Okay, so 5 and 6, did you say they're related or what?
The constant current area of the effect lie between.
Saturation and
Now, pinch off.
breakdown and pinch off.
Right. That's the air current area. Constant. IDSS. Okay?
Okay.
And we already done for number 9.
Mm-hmm.
Just wait for me. I want to change something here.
So, Mr. Fan,
Yeah.
the number 8, the FET is a saturation area, right?
Yeah, just wait for me. Okay. Oh, man. Okay. Get it back. Okay. Now, what's your question?
The FET in number 8 is a saturation area. That's the reason is the same comment.
You mean in the number 8, right?
Yeah.
Okay. So the question is, if they changing the value of RD, they asking for what the IDSS equal. So we get it equal 15 milliamp. The reason is they already given you VGS equal 0. So VGS equal 0, then ID must be equal IDSS. Doesn't matter what the RD equal.
VGS is on the x-axis and IDSS is on the y-axis. So if VGS is 0, then you can only go straight up on the y-axis, which would give you IDSS at max.
That's what you guys have to memorize. What is the IDSS? Basic definition. IDSS is the maximum current when VGS equals 0. That is the basic definition. So VGS equals 0, then ID cannot be equal to anything else except IDSS. Okay, number 10. A certain JFET data given, VGS up equal -4. The ping up voltage VP. The answer will be D. If you not quite follow it, let me know. Otherwise, we cannot review everything. You understand VGS up and VP, they're the same value. However, they will be opposite polarity. Okay? Number 11. JFET in the question number 10. What channel? The answer will be A channel, N channel. Answer will be 11 will be A. You know why? Why N channel? This is a very, very basic thing I given to you guys.
The pinch-off voltage is +4, so VGS off has got to be -4. Because you said pinch-off voltage VP cannot be determined. But you said the answer is D.
They asking you on number 10, they given to you, they asking you, is it an N channel or P channel? I say N channel. Do you now want to know why? Why I say N channel? Who tell me?
Is it because VGS is negative?
Yeah, because G is negative. Yeah.
Exactly. They given you -4 volts.
Right.
Yeah.
So that must be N channel.
To reverse the junction. Yeah.
Positive than P channel. Okay, 11A. 12. A certain JFET IGSS 10 nanoamp VGS 10 volt input resistance. The answer will be 1 mega ohm. You just get one formula I can remember to do calculate that.
So the answer is B then, right?
Yeah. You calculate, you can see it. 13. A certain D MOSFET is biased at VGS equals 0. Its data sheet specify IDSS 20 milliamp, VGS of -5 volt, the value of the drain current ID. 13 answer will be C, 20 milliamp. Any question on that? If it's not, I can tell you, the MOSFET working like JFET. Okay? So VGS equals 0. ID must be the same ID at 20 milliamp. They working the same JFET. Number 14, and channel the MOSFET with a positive VGS is operating in The answer will be C. Cut off. The thing is, the MOSFET will be working with the negative VGS off, okay? 15, a certain P channel E MOSFET has a VGS TS equal minus 2 volt. If VGS equals 0, then the current, the drain current is the answer will be ID on. You know the formula to calculate the ID on. And what is the ID on? Who's telling me what is the ID on? No one telling me. Okay, I'm telling you. ID on, that means the current at VGS equal 0. That is the ID on.
Mr. Pham,
Yeah,
number 14, shouldn't that be enhancement mode?
and channel D MOSFET
Positive.
VGS.
Isn't that enhancing it when you put?
Now they will be in cutoff.
Okay.
Okay, so number 14, maybe I have to double check it later.
I think it's enhancement mode. I'm just looking at the slides. An enhancement MOSFET is an N channel with a positive
Okay,
voltage from gate to source.
yeah, I think you're right. That will be B. So some reason, this arrow going down. The thing is VGS positive, okay? You can get the MOSFET, they can be either depletion or enhancement, depending on, you know, depletion VGS will be negative, okay? And positive, they will be in enhancement. Sixteen, common source amplifier. The output voltage a first thing, they will be 180 degrees out of phase. And the second thing is taking output from the drain. Answer will be D. That is the lecture, okay? For small signal operation, an N channel JFET must be biased at VGS must be higher than minus VGS off and less than 0. 17 will be C. 18. If there is internal open, between the drain and the source, okay, in common source amplifier. The drain voltage equal to, answer will be VDD. You understand the same like in bipolar. When they get open, that means the ID equal 0. ID equal 0, that means no voltage drop across RD. So that will be telling you, okay, the drain to the source, okay, amplify internal open, drain and the source, okay, common source amplify. The drain voltage equal VDD. The thing is ID equal 0. No current drop across RD. Okay, that number 19, 18. Answer will be B. Okay, so that will be number .
Mr. Pham,
Yeah.
can you go back to question 4? Thank you.
1, 2, 3.
And question 7?
Right here. JFET always operate with gate to source PN junction reverse bias. At the beginning of the handout, reading that.
Also, can you go to question 7, please?
7.
Yes.
Drain current in a constant current area increase when the gate to source, that means VGS, voltage will be decreased.
Okay, okay, thank you. Can I also see question 9?
It cut off. JFET channel completely closed by depletion region. That means depletion will be tied together. No
Thank you.
Okay.
I just needed to see those questions, Mr. Pham.
What else?
That's all.
Okay.
The 12, what's the answer?
So any more questions on tree number 1?
Question number 6.
Number 2, 3, 4, 5, 6. IDSF. The answer will be the maximum possible drain current. No more ID can be higher than IDSF.
What is the answer of 12, please?
You go number 12?
Yes, sir.
Okay, that one you need to open your handout to try to see what the input resistance equal using that formula to calculate it. If you cannot get any answer, A or B or C or D, let me know tomorrow.
Thank you, sir. Thank you.
Number 2. Oh, man. Okay, number 1. They want to know V8 for this circuitry. How come they not show the answer here? Okay, I stop on that one. Okay. Okay. For this circuitry here, they want to know what the V8. They already given you ID, 1.7 milliamp. Same thing. The current ID, I have the same. You want the V8. Just take the current time at 2.4 kilo ohm. The answer number 1 will be A. Number 2, determine VGS for the circuit shown. The answer will be minus 4.08 volt. Number 2 answer will be C. You understand VGS equal VG minus VS. VS already get 4.08. Then VG will be minus 4.08. Number 3, they want to calculate the VD. You already get the ID. VD will be equal to VDD minus ID times RD. The answer for number 3 will be B like the boy, 9.46 volt. Number 4, N channel, the MOSFET with a positive VGS. Okay, this is the answer will be same thing on the number 1. Correct answer will be enhancement mode. Number 4 will be B. Number 5, they want to know VG for the circuit shown. You understand that the same voltage divider. You take VDD times R2 divide R1 plus R2. And you will be get 18 volt. Number 5 will be B. Number 6, they want to know the K value And I already given you the K value. Formula equal ID on divide VGS on minus VGS DA. Okay? Everything they already given to you here. VGS DA 5 volt, ID on 3 milliamp, VGS on 10 volt. And the answer will be number 6A, like Apple, 0.12 milliamp per volt square. That you guys have to do your own calculation. I'm not trying to do any calculation. Just giving you the way how to get the answer. Number 7. They want to know VGS. Okay, that's a VG. That will be at VGS. The answer will be 12.5 volt. Number 7 will be C. Number 8, they want to know VDS. VDS from here to here. They will be equal VD minus VF. Okay? You have to know the VD and you have to know a VF. That's why you can get VDS. The answer will be A, 14.4 volt. Number 9. They want to know IDQ. Okay, so basically on this circuitry, okay, common source amplifier. However, they're using the cell bias. Basically, you need a graph to calculate the DC bias. However, they given to you VS already equal 1 volt. Right here, you get a 1 volt, and you can get the current IS easy. IS equal VS divide RS. And that IS and ID will be the same. Okay, so that's why you can get ID. Number 9 answer will be 2 milliamp. That will be C. Number 10, they want to know VGS. Okay, VG S equal VG minus VS. VG equal 0. And VS we already calculated. And they already given to you 1 volt. Then VGS equal minus 1 volt. For number 10, answer will be B. 11.
Hey, Mr. Pham, can you just do 7 and 8 real quick? I just want to look at them real quick.
Which one?
7 and 8.
VGSQ. VGS equal VG minus VS.
Okay, I got it, Mr. Pham. You can go back to whatever one you were at.
Okay, number 10, right? That's
11.
Done. 11. They want GM0. You know the formula to calculate the GM0. Okay, they already given you IDSS. VS equal 1 volt. Okay, VGS of minus 2 volt. Then you get the formula for GM0. You can do calculation. You get 12 millisiemens. That means 11 will be A. 14. Then now they want to calculate the GM. Using the formula for GM, you can get answer will be 1 millisiemens. That means 12 number B. They want.
Hold on, can you go back over number 12? I don't think that is correct.
Okay, what the formula? What the GM0?
GM, yeah. GM equals GM0 times the quantity 1 minus VGS divided by VGS off.
So which one is wrong, 11 and 12 or both?
No, number 12, number 12. Number 11 is good. Number 12 is the one that I got 6 millisiemens, not 1.
Okay, now, who tried to do that calculation to me to see what we get? So let's see, GM
equal GM0 times the quantity 1 minus VGS off, VGS divided by VGS off. So yeah, GM0 is 12 millisiemens times the quantity 1 minus VGS was -1.
What VGS equal?
VGS is -1. And VGS off is -2.
Okay, so you calculate, you don't see any answer, right?
Yeah, so you got, so 1 divided by 2, so that's be 0.5. So 1 minus 0.5 is 0.5. And 0.5 times 12 millisiemens, that would be 6.
Okay, if you do calculation not matching A, B, C, so you can select D. However,
Okay.
make sure you know how to calculate the GM.
Correct.
13. They want to get the output impedance. Output impedance, they will be parallel between RD and RL. My answer will be 1.3325 kilo ohm. 13 will be A. You get that? $1.325 kilo ohm. Okay. And number 14, they want calculate the voltage gain. 14 will be minus 1.33. 14 will be C. If you want it, you have to go back into the common source and get the formula to calculate the gain. Basically, I just given you very, very basic.
Very, very good, Mr. Pham.
Okay, so you already get review 1, review 2, review 3. And only left over, review number 4. Will be run quickly tomorrow. Okay, Sam, to look into the review number 4.
Yes, sir. I will be prepared for number 4.
Okay. So
if anybody else that did not see the name on the list that I showed you, please let me know. Either type in the chat, and so I can collect your name, and then we'll just have to confirm it with. I will check out with Mr. Pham later. Okay.
My name was already entered in just earlier.
Yeah, I typed it in here, but you need to go register on the website.
I don't know how
the
to
link that I put. I did put the link on the on here. That Mr.
You want to help me?
I think Mr. Javon was asking for earlier.
Sam, you can share the screen.
Okay, hold on 1 second. Please.
So how do I register for the thing?
Okay. You still sharing, Mr. Pham? You need to stop sharing so I can share.
Oh, sorry.
That's okay.
Okay.
Are we all set for tonight?
Stop recording.
Yeah, yeah. Everybody else is good to go. If you already have your name, you got your register. Everything is confirmed, and you're good to go. And then there's other student that's still not. They still have not got their name. So I put you on the list here, but you still need to go to the website, right? You go to the website. I did put in the chat room. You have to go to this website. Here you have to put in your student ID number and your student password. Okay, let me go. Yeah, right. That's where you need to go to. Okay. Let me see. Go to the website. Let me go ahead and enter my number in here to get in. And so I can show you 2, 5, 3.
Hey, so Mr. Sam, you see my information, right?
Just
I shared it.
Just kind of tied up over here.
Okay, yeah, sorry, my bad.
Right. Okay, so when you log into the portal, it would take you in here. Just click on this, click on the close. And then you want to do is you want to go to your CE student dashboard. So for me, it's this one here. And then it would take you into right here. Okay, so it said welcome, whoever you are, right there, like Javon has on yours. Okay, and then you want to do is you want to come in here. The first thing you want to do is go call CE Continue Ed Apply. So you come to the right side here, click on that, and then you're going to fill up your personal information, and you're going to be applying for the spring 2022 semester. Okay. Once you have completed that, then it will bring you into, then they get you to be able to enroll. And then you come in here and you click the word enroll. And then right here, you want to choose what term that you're going to be working this semester. So for this one, it's going to be spring 2022. And once you choose that option, click on continue. And once you're done, you come in here and you type in the class number. It's a 5-digit number. You type in here, press enter, okay? So for this class, for example, let me see what the class number for 86. So I'm going to just copy this one to use for now, copy. So I'm just using this as an example, paste. So I put in my class number here, I press enter. Now they give me a list of the class and who's where it is and who's the instructor. And then after that, I click on say proceed to step 2 of 3. Goes in here, and then you just have to review what the class is. So you want to do this technician 2, and it's going to be time, it's going to be to be announced, room, it's mid-city, and then on the web. Okay, so we're going to work on online, and the instructor is Mr. Tuan Lee and Mr. Hua Pham. And then you click on finish enrolling, click on, so you click on that. Okay, so mine, because I didn't enter the permission number, I got the status not good. So I had to go back and go back into here. And so control paste, enter. Now you come in here, usually there's a list right up here that your enter permission number. Okay, it looks like mine doesn't have it because I'm not registering for class. So it would ask for your permission number somewhere here. Once you've done that, then you click proceed to step 2 or 3. Okay, so we did give you the information. First thing you want to do is you want to have the class number. Next thing you want the permission number, which is its 6-digit number. Okay, so that's why we give you whatever the red one that goes first. Then the second one is your permission number that will go into this here. It will be somewhere up here, and it would you type it in, and then you click on proceed to step 2 or 3 once you enter that permission number. Okay, this class already in the shopping cart. That's why I can't do it again. So just click on here. Here it is where they ask for permission number right here. Okay, and then you have to type in that 6-digit. And once you have that done, you click on next. So I'm not going to use these digits because I want to reserve for. We're going to reserve these numbers for the student, okay? So I'm just going to put example right here. You enter your name, and then you click on next, and then you just read, just to confirm, make sure it's the right class, and then you can proceed to the next step. And then once you click on the end, where say for example, I know that mine is not going to go through. So, and then after that, say proceed to step 2 or 3. And here you just have to do just confirm all the information. This is an open class, so you can open enrollment. So you come and go as you need to, and then you click on finish enrolling. Now, when you finish enrolling, when you get a green check mark right here, that means you're enrolling class. But if you get the red X here, that means something's wrong. So make sure you contact the instructor to make sure that you get the right number. Okay.
Sam,
you probably.
Excuse me, Sam.
Yes.
Are you displaying like one screen versus multiple screens? Because all I see is just Jovan's screen and that's it. So if you've been trying to instruct on another,
did he share the screen? I didn't get to share my screen at all.
Sorry, my bad, Sam.
Yeah.
I only shared my screen so that you can see that I had enrolled.
Whatever you went through, Sam, we missed all of that.
Okay, I'm sorry. All right, so yeah, just go ahead.
Let me stop sharing.
Thank you, Jovan.
But you got my
you
got my info, right?
Yeah, thank you, Jovan. Okay, so sorry about that for going over that and not getting the information. Okay, so like I said, let me go ahead and go back.
Yeah, there we go. Thank you.
Okay, let me go back into my class. Okay, so I'm going to go back all the way to the beginning. Okay, when you log into the portal, and so it would bring you in here. Now for you, you're going to have just the CE student dashboard. So, but mine have multiple things because I'm an employee and I'm working through the school. So you want to do is yours is going to be, when you come in, you're going to be seeing this welcome page right here. Okay. So welcome page right here. Then you want to do is go in here, click on this, say CE, continue ed, apply. Okay. You click on that. That means from there, they're going to take you to fill up some of your personal information, update your personal information. Maybe you got change of address, change of email, or maybe change of phone number, then you need to update it, okay? So, and then you need to update that. And once you're done, then you can, and then it will bring you back out here. And then you can go into this one and then click enroll. And we'll take you in here to enroll for class. Okay, click on enroll. Okay, so I tried to load the other things on there earlier. Okay, so this one is take to your application. And so the application, you come in here, said apply to continue ed only. So you click on here, click on that option. And the term, so here the term, there's usually an option, so that's only spring 2022 that's coming up. So click on that and click on next. And then here, I already updated mine, so therefore I don't need to update my application again. So I can click OK. And then my personal information is up to date, so it's good to go. And then right here said adding classes, and then click on spring 2022 to add my class. Click on continue. Now here, the class number, then here I can go into the class number that was given to you. So this is class number is in red, so 84662, okay? So I come in here, type in 84662, and then press enter. Okay, now I already have one in here. Let me go ahead and delete that. Okay, so now I have nothing in my shopping cart. So now I put in this one, press enter. Now they show you, okay, so this is telling me, okay, now it's taken to here. Now they ask for the permission number. Now I'm going to just use, I'm not going to use the number here. I'm just using for example. Okay, so next thing I'm supposed to put in was the permission number. Say this number, for example. Okay, so I'm not going to use that person's number, but I'm just using example 1, 2, 3, 4, 5, 6. Okay, 6-digit number. Okay, put whatever it is according to your name, whatever you correspond to your name. So this is your class number, permission number. Okay, so that's what you're going to be typing here, permission number. And once you have done that, click on next to go you to the next page. Here you want to just review everything. So here's a class number to be announced. mid-cities. So this one here is showing. Okay, they said mine's already in shopping cart, so therefore, okay, so that's why I don't need, I should not, okay, so I go in here to look at my shopping cart. Okay, so that's got my permission number and enter all that permission number. So click on next. Here, you just want to review the whole thing. So class, day and time for the class, room number, it's going to be at Mid-City, and mainly we're going to work on the web. So partial, half and half. Mid-City is at when we're doing the lab, and the other side we're going to be working online like we've been doing on lecture. And the instructor is Mr. Tuan Lee and Ms. Hua Pham. And this is an open class, open, close, so you can come and go later on. So you can come in here and then click, and here you click on say proceed to step 2 or 3. Okay, so from here, it takes you here. Okay, so now just kind of review this, make sure everything is correct. And then you click on finish enrolling, okay? Now, right now, like I said, here is where the end result, okay, so right now they said mine is error. They said permission number is required, so I got the wrong permission number. So therefore I had to contact the instructor, get another permission number, okay? But if you get a green check mark, that means you enroll. That means you successfully enroll, which is right here, okay? With the green check mark. So if you get a green check mark right here, you're good to go. So click on, okay. If not, then contact the instructor so we can help you fix this, okay? So that's pretty much how you go through and then enroll for the class. Okay, any other question? Let me go look at the chat real quick. Okay. Okay, so that's pretty much it. So if you have any questions, just watch the video that Mr. Pham will be uploaded to the website, and so you can go through it, okay? Thank you very much, everyone. So anybody have a question?
Okay, if it's not, good night.
Good night.
Okay, so that's good night.